we have this quiz about two logicians, and it was posted by the YouTuber MindYourDecisions. So, this is a very interesting. This is a very interesting riddle, and I need your guys' help on figuring out how to model the logic properly and how to define the difference. You know how when we define what a proposition is, so then we can explain the statement. This statement is false. So two logicians, A and B, they pick a whole number from 1 to 30 inclusive, and then they ask each other these questions, and we get an answer. Now, here is an answer that MindYourDecisions explains here. So if we read this, we can see that if we start with A, he asks, is your number double mine? Okay, so we know that A has some number between 1 and 30, and B says, well, I don't know. Is your number double mine? So B doesn't know, so if he doesn't know, then we know his number must be even. Because if it's odd, it can't be a double, so he would have answered no. He wouldn't answer, I don't know. So he asks A the same question. A says, I don't know. But since A already knows that B's is even, then A's must be a multiple of 4. But then he asks, B, is your number half mine? B says, I don't know. So then we kind of are left with this, all the halves of A, which is fine because all we knew is that they were even, or at least that's, so far, that's what he claims, we think we know. Now, I'm going to point something out later, but I'm just explaining his solution here. So then B asks A, is your number half mine? So that means that A, right, we already know that A has one of these even multiples, one of these multiples of 4 up to 28, right? It's got to be nothing outside of this set. But A says, I don't know, if mine is half of yours. So that means A's must be limited to 1 through 7. So the only number in both of these sets is the number 4. And so his conclusion is that 4 is the answer. Now, if we go back and we look at what A is asking, A is asking, is your number double mine? Now, if he were to ask that to B, he wouldn't be gaining any new information. He wouldn't be acting as a perfect logician if we're assuming that they're going to ask logical questions which are going to help them figure out the answer. Now, what's really interesting, I just want to know how to model, how to define what the correct answer would be, or how we would define the question in order to get this a different type of result or get a different type of reasoning here. Because if A is asking that question, really we can kind of almost infer, if we assume that his question is gonna be purposeful, we can kind of infer that his number is only 1 through 15, because B can't be can't have if B's number was more than 31, it would be outside the scope of the problem. 31 or greater, he knows B's number can't be 31 or greater. So if A's number is bigger than 15, like say it's 16, we know that B's can't be 32. So asking that question isn't necessarily going to make the most sense. If he already knows the answer to the question. If he already knows the answer, that there's some kind of presumption if we define the questions in a certain way. Now I get it. He could still ask the question even if he knows the answer to gain some information. However, I'm just going to go through here and we're going to just assume. We're going to add the assumption that the logicians understand that they're going to be asking questions which are purposeful. So this already conveys that A has the number 1 through 15. So now B, since he doesn't know, we know that he's going to have an even, but he also asks, is your number double mine? So then we can also A assumes that B is asking a purposeful question that he wouldn't already know the answer to. So his would actually be limited to the even numbers, less than 15. So we have 2 through 14 evens here. And then he asks, is your number, and then A answers, I don't know. So now we already know that A's must be a multiple of 4, but it's still limited by 15. So now we know that A's set is only just the multiples of 4 between 4 and 12. But then A asks, is yours half mine? And when B says, I don't know, well, there's only, and I should actually change this because this is only 3 numbers here. B would only have the options 2, 4, and 6. So then when B asks if A is half his, as soon as A says, I don't know, he's saying that his numbers would be from the set 1, 2, and 3. Because he doesn't know if it's half his. But if he knew it wasn't 1, 2, and 3, he would know. So now we don't have a solution, but I'm sure there's another way that you could write this problem where the logicians assume that they're asking purposeful questions, and then they basically come to a result. So I just thought that was very interesting. And I noticed there was a lot of commenters, so I wasn't the only one who noticed this. There's a lot of people who kind of pointed out about how this question worked. Because a lot of times these logician questions, they kind of assume sometimes that the logicians are perfect logicians, or they're asking questions like optimally in some sense. So I just thought this was really interesting because it seemed to follow propositional calculus, even in this solution here, but it's just kind of silly if you think about it, because this actually points out how the English language works, how people reason about things. If you ask a question you already know the answer to, it doesn't change the fact that it's a valid question, that it's a proposition. And if you follow just the propositions, you can get some, reality information about reality in a different way than what people would think is logical. So, yeah, I just want to get some more comments because I want to kind of go more in depth in this kind of question here. I thought it was actually an interesting thing to point out, an interesting way to help model reality, because as a programmer and as somebody who likes to come up with proof systems and things like that, I like to think about how we actually model reality in language, and logical reasoning is a very interesting thing to me, for these type of applications. Not for the application of using the puzzles, but using the puzzle as an example, as a way, kind of like a practice example of how we, apply these, attempt to apply these different logic systems to reality. Okay, so let me know what you guys think in the comments. I'm interested, and maybe there's a formal, different types of formal logics, like the difference between intuitionistic logic and propositional calculus is very interesting because it just removes the double negation and replaces it with something else, but it has very interesting properties in the sense that you can always, reduce, like prove what the types are, or reduce. You give up completeness for consistency. So let me know what you guys think in the comments. I really want to explore this question more. And did you think it was fair, the answer that he gave? Was it fair, or is this something that would actually need to be addressed? So see you guys later.